pick back up talking about these intervals and inequalities. This next section said to write an interval of real numbers using an inequality and draw the graph of the following. So we're basically taking what we did in the first section and reversing it. They gave us an inequality, we put it words and graph. Now we're doing just the opposite. So the real numbers between -4 and -5/10. How do I express that as an inequality? Or would you rather do the graph first? I could go either way here. Okay, what do you got for the inequality?
Would it be -4 less than x less than -0.5?
Mm-hmm. If you use the last one we did yesterday as the example, reverse it. Anytime it says the real numbers between something, you can put x between those numbers and use 2 less than signs. Now, he said less than. Is that correct, or does it need to be less than or equal to?
Just less.
Okay, it does not say including those numbers. It just says between those numbers. So they would just be less than signs. Let me get my graph set up here because I don't think that's where you need my help. Or I'm setting up my number line, I guess I should say. I just numbered by ones, but I threw in the -1/2 there. Where's my graph go?
You put a parenthesis at -0.5 and -4.
Okay.
Does the parenthesis go like in front of the line, behind the line? It doesn't matter.
I'm going with on the line. I mean,
like
what?
Through my line.
On the number line.
All right.
Are you talking about like through the little tick mark? Is that yes, through the on the tick mark, through the tick mark, because it is at that number. Is that the question I should be answering there?
Yeah.
Okay. Okay, so your graph should look something like that, right? And notice my parentheses are opening in towards wherever the shading is. Okay, good. Real numbers greater than or equal to 0 is part B.
X greater than or equal to 0.
Yeah, real numbers greater. Real numbers, that's just X right now. Greater than or equal to 0. That's the one that points to the right. Greater than or equal to 0. And set up my number line. How's that graph look?
A bracket on 0 and then a line.
Okay, and that line is going to the right. Okay. Now we've got to talk interval notation here, which we did do a little bit of interval notation in Algebra 2 at least, because I just started my very first day of notes in Algebra 2 this morning, and when we talk about domain and range, we use some interval notation.
I think we use the brackets and the parentheses. We just haven't done it like on the graphs yet.
Okay, maybe, okay, that can be then.
Because the bracket and the parentheses is like familiar, but it's not familiar like graphy wise.
Okay, and I felt like it should be familiar at least somewhere out there, but okay. Well, and I know I introduced domain and range this morning, and we were talking with inequality symbols, but we were also talking with interval notation.
Mm-hmm.
So maybe just not exactly in the sense I was thinking. Okay, so on A, we have the interval notation, -6 to 3. And they're asking us to what? To convert this from interval notation to inequality or vice versa. Technically, do we have to do a graph?
No.
Technically, no. Can you throw a little graph in if that's going to be helpful to you?
Mm-hmm.
Yes, and that's my suggestion. If you're looking at that saying, I have no clue, then I'm going to suggest you visualize the graph. Okay? And, you know, this doesn't have to be a fancy graph, but If I just kind of visualize the graph, what does the interval notation -6 to 3 mean?
Real numbers between -6 and 3.
Real numbers between -6 and 3. So that means my shading is, it starts at -6 and it ends at 3. -6 has a bracket, 3 has a parenthesis. Okay, so that, if you need that sketch, you didn't have to do that right there, but there's a little graph to help you visualize it. How do I write that as an inequality?
-6 less than or equal to x less than 3.
Because what are we doing? It's all numbers between -6 and 3. Okay, now if you're someone you'd rather break that down, think about it. Does it make sense? If we just look at that part right there, x less than 3, is that what's going on? X less than 3. Now, if we just look at this other part, -6 less than or equal to x, reverse that in your brain if you need to, and think about this as x greater than or equal to -6. Is that what's happening? It is. Okay? So, some of you that's a piece of cake for, some of you it's a little harder to process through. So, okay. Thoughts on B? -infinity to -1. What is that as an inequality? And again, if you need the graph to get you there.
Isn't it just going to be x less than -1? Or do you need the negative infinity?
No, not for inequality. Okay. Because what's this interval notation look like? -infinity says it starts shading here at the left and we stop shading at -1. Well, if you look at that graph, where is that shading? All that shading is to the left of -1. So x less than -1. I know sometimes you'll see set notation and they'll say -infinity less than x less than -1. To me, that's not an inequality though. Okay, that's something fancier. Okay, C. They're giving me the inequality. I want interval notation. -2 less than or equal to x less than or equal to 3.
-2, 3. And they both have brackets.
Okay. This is x is between them, right? So my interval starts at -2. It ends at 3. They're both equal to. So they're both brackets. Now, again, you do you. If you is better sketching a graph, and I don't know, maybe everyone's saying, nope, I don't need that. Whatever. Okay. Less than or equal to 3. I'm going this way. This is greater than or equal to -2. So I'm going that way. It all drives, right? Okay, questions there. Because one of the things you're going to have to do in homework is be able to write inequalities interval notation. When we get to, I can't remember if it's the next lesson, but somewhere a couple of lessons here, we're going to be solving inequalities. When we're solving inequalities, guess how we're going to be writing the answers? Interval notation. Okay, that's one of the things we're going to practice. Okay, the bottom of this page, we have some properties. These top 5 properties, oh, I don't know, some of these you've been doing since I feel like kindergarten. I know that's crazy to say, but I know some of these I learned when my kids went through elementary that you start talking about these really early. Commutative property just says that 2 plus 3 is the same as 3 plus 2, works for addition and multiplication. Okay, associative property says that if this is 2 plus 3 plus 4, well, I can do 3 plus 4 and then add 2. Or I can do 2 plus 3 and then add 4, right? Just saying multiple numbers, it doesn't matter what order I add. This holds true for multiplication. So you've got the associative property of addition or of multiplication. Same thing of commutative property. Distributive property, you guys know that one, right? Distributive property says you can take this number that's out front and distribute it. So that's xy plus xz. If that x was out back, you could do the same thing, right? You could distribute it from the back as well. Okay. Identity property. An identity property says how do you get the number you're starting with? So in terms of adding, how do you get what you start with? In terms of adding, we just add 0. So the identity property of addition is just you add 0 to something, you get what you started with. Multiply. How do we get what we started with if we're multiplying? Well, in order to multiply and keep the same number, you multiply by 1. Those are your identity properties of addition and multiplication. And then the inverse property says, how do you get the identity? So when adding, the inverse property says, how do you add to be 0, which is the identity? And how do we add to get 0? You take a number and its opposite. It's negative. It's opposite is probably the official math word there. If we're multiplying, how do we multiply to get 1? You take a number times, this says x to the negative 1 there. That's probably not what you would really think. I don't have it written in my notes, but what is x to the negative 1? What does that negative exponent do? Yeah, it moves the x to the bottom. So what is x times over x? The x's would cancel and you would have 1. Okay, so inverse property just says how do we get to the identity. Those are properties you should be familiar with. There are a few in homework where you have to identify the property being shown. When you identify the property, don't just tell me commutative. Is it commutative property of addition or of multiplication? Because you will be expected to have that for the answer key. Okay? Exponential notation. Okay, we're going to talk exponents. Remember vocabulary. If it's a to the m, a is the base, m is the exponent. Now, we've got some important properties here that we sometimes tend to forget. So, we'll practice these on the next page a little bit, but they're going to be more difficult than just the basics here. U to the m times u to the n. What happens when you're multiplying and the bases are the same? Keep the base, and the shortcut is to add the exponents. When you're dividing and the bases are the same, keep the base and subtract the exponents, right? Now, what if we have a power raised to a power? Keep the base, of course. Power raised to power, well, that's when you're going to multiply. As opposed to up here, there were 2 separate bases. UV to the m, that's just saying that that power that's outside goes to each piece of the base. So that m goes with the u and with the v. Okay, and it only goes, those things are multiplied in there. This is the division version of this. The m goes with the u and with the v. This is an important one. Do you remember this one? Anything raised to 0 power is 1. It's a good rule to just know. Your calculator will reassure you of that if you forget it. Okay? Just saying. And then we just talked about negative exponent. What's a negative exponent do? It takes that power to the denominator. Right? Okay. Let's run through. Oh, and top of the next page, scientific notation. Okay, C times 10 to the m, where C, for scientific notation, remember that C value has to be some number between 1 and 10. It can be as small as 1.0 or as big as basically 9.999999, right? It cannot actually be 10. And m is some integer. So that means the exponent won't be a decimal or fraction. It's some positive or negative whole number. Okay, let's go through some examples here. Identify the base and exponent. Pretty easy, but I want to make sure you see the catch here. Negative 3 to the 5th. What's the base? Negative 3. What's the exponent? 5. Piece of cake there, right? Okay, what about b? Negative 3 to the 5th again. What's the base? Not quite.
3.
base is just 3. What's the exponent?
1.
No?
Negative.
No? You're reading too much into it.
5.
Just 5. Now, what's the difference between these problems? Because there is a difference. The parentheses, right? What's negative 3 to the 5th mean? If we were to work this out, this means five negative 3's, yes? Because that negative is in the parenthesis. It means whatever's in that parenthesis multiplied 5 times. What does negative 3 to the 5th mean? We just said the base was 3, yes? This negative is just hanging out in front here, so what this really means is there's one negative and then what? 5 3's. Okay, sometimes you'll see it expressed as this. But when there's no parentheses there, that's just saying that whatever 3 to the 5th is, the negative of it. Now, I'll be honest, these actually work out the same answers here, but that's because it's an odd exponent. If it was an even exponent, it wouldn't. Okay, let's apply these exponent rules. So A, 2ab to the 3rd times 5a to the 2nd b to the 5th. We went from some very basic exponent rules on the previous page to, okay, we're going to throw it all together here. Guesses? Thoughts?
Would you do 2 times 5 and then it'd be a to the 3rd and then b to the 8th?
Yeah. What is 2 times 5?
10.
And why are we just doing 2 times 5? 2 and 5 are just regular plain old everyday whole numbers, right? The A, you have an A to the invisible 1 and an A to the 2nd. If the bases are the same and we're multiplying, we're going to keep the base and add the exponents. The B's, if the bases are the same, we're going to keep the base, add the exponents. So final answer there, I'm looking for 10, a to the 3rd, b to the 8th. Are we okay with that? Maybe we goofed it up along the way, but it seems familiar, I hope. Okay, what about B? U to the 2nd, v to the negative 2nd, over u to the negative 1st, v to the 3rd. And there's a couple different ways we can think about this, so. See which direction you guys guide me.
Can you multiply by the reciprocal?
Depending how you mean that, we don't want to multiply by the reciprocal.
But like the opposite of each one. Did we do something like that last year?
Well, if we're multiplying by the reciprocal, we're changing the value of this expression.
Okay.
So we don't want to do that. I don't know. You might be on the right track, just not exactly expressing right. I'm not 100% sure there. And there's, as I said, I definitely have 2 different ways I could go about this depending on your mood and what you see.
Would it be u to the 2 minus 1 and then b to the negative 2 minus 2?
Okay. So one option, when you have like powers or like bases on top and bottom, the shortcut is to keep the base and subtract the powers, yes? So one option to think about here is you could think about the u. If we look at u's, there's a 2 on top, a negative 1 on bottom. So 2 minus negative 1. With v's, v on top, v on bottom, subtract, and that is negative 2 minus 3. What do those clean up to be?
U to the third,
U to the third, V to the
negative 5.
-5. Do we get to leave our answer like that? No. Savas would have counted you wrong last year. You don't have Savas, but I'm going to count you wrong or count off a point on the test if you leave it here. One more step. Why can we not leave this answer as is? You can't leave a negative exponent. How do we get rid of that negative exponent? Okay, make it a fraction, move it to the denominator. What about u to the third? It stays, right? It's positive. It's going to stay on top. V to the -5th, we're going to move to the denominator to make it a positive exponent. So u to the third over v to the 5th. Now, the other option of how we could have done that. I don't know, maybe I shouldn't even mention it. If you're someone you tried to get rid of the negative exponents first, u to the negative first, you moved it up top, v to the negative second, you moved it down below, then you could have just added your exponents in each case. But I was more wanting to teach the subtraction anyway. So. Okay, C. Again, I could come up with two different ways to do this one.
Do you distribute the -3?
Okay, so, and I'm actually going to have a different way I'm going to lead this, but one option is what? That -3 goes with top and bottom, yes? And what does that become when we do that? X to the
-6.
multiply, so -6. 2 to the -3rd. Not my traditional way to do this, but it works. What's the next step you have to do? No, because my bases aren't the same.
Would you move x to the -6 to the bottom? Would you take the 2 to the -3rd?
And where was it going to go?
Top.
To the top, right? So to get rid of a negative exponent, you move it across the fraction bar. If normally we say we move it to the bottom. If it's already in the bottom, we're going to move it to the top. So then it becomes 2 to the positive third on top, x to the 6th on bottom. There's only one little other thing I could say you could do here. 2 to the 3rd is actually a value. What is 2 to the 3rd? It is 8. Because it's 2 times 2 times 2, not 2 times 3, right? Now, I'm not saying this is any easier or quicker, but a common technique. When you see a negative exponent on a fraction, a common technique here instead would be to say, okay, that negative is going to take this fraction. What did it eventually do? It took the fraction and flipped it, yes? So a common technique would be to say, okay, I'm going to make this 2 over x to the 2nd raised to the positive 3rd. Okay? Just showing that because that's the more common technique than the way we went through it. Nothing wrong with the way we went through it. Because both ways, what are we going to end up with? 8 over x to the 6th. Okay? D, how do I expand that? Okay, that x is hanging out back, and we're going to distribute it. So x times a, I'm actually going to think of it as a times x, ax, plus x times 2, 2x. On the ax, xa, doesn't really matter. 2x, x2, you guys know at this point, 2x is the common way to do this. I shouldn't have boxed this yet. Am I done here? And I'm done because these are not like terms. Okay? E, it says to factor. And FYI, that is a 3y minus by, just so you know. How do we factor? Yeah. What is that y called? GCF? Maybe? I don't know if that's what you guys were going with that or not, but yeah, we're factoring out GCF here. Y is in common, factor it out front or out back, and then you have 3 minus b. Okay, good there? One last little topic. And I'm going to tell you, do not grab the calculators for this. Okay? There's one thing we might grab calculators for, but generally speaking, don't grab calculators. So, convert the following to or from scientific notation. A, 2 and 375 thousandths times 10 to the 8th. What do you remember? How do we convert in this one out of scientific notation? Okay. This positive 8 says you move the decimal 8 places right, yes? So, what do I have? 2.375. 1, 2, 3, 4, 5, 6, 7, 8. Am I adding 8 zeros? No. Okay, 8 zeros is what you added when you first tried scientific notation, but we've grown, we're past that, yes? So 2, 3, 7, 5, 1, 2, 3, 4, 5 zeros. And how do we put commas in a number? Yeah, every 3 numbers from the back end, yes? Okay. What about B? It's a decimal point, I don't know how many zeros, and then a 349.
It's 3.49 times 10 to the negative 7.
So why are we making it 3.49? We're trying to make that main number a number between 1 and 10, yes. So that's how we know where to put the decimal there. And then it's times 10. Did you say negative 7?
Yeah.
Okay. Why'd you use negative?
Because you're going the different way.
Yeah, and I can never say left or right here. Here's what I look at. I look at a positive exponent gives you a big number much bigger than 10, yes? A negative exponent gives you a decimal number. That's how I don't think left and right because I just can't on that one. Do you guys agree with her 7? Okay. And that is how many spots between decimals, right? There's 6 zeros plus that 3, so 7 numbers between decimals. Okay. Now, C. Easy option would be to just throw this in the calculator. However, I'm going to challenge us to not throw it all in the calculator. We might do a small piece of it in the calculator. This is not in scientific notation, correct? Mm-hmm. So that means our job is to put it in scientific notation. There are some, it'll make life a little easier if we put it in scientific notation before we multiply and divide. So let's review a little bit. What about 370,000? Times what?
10 to the 5th.
Okay. 3.7 times 10 to the 5th? Sounds good to me. What about, what is that, 4,500,000,000? What's that one going to be? Is 9 right? Yeah. Okay. Okay, denominator. What's 18,000? 1.8 times 10 to the 4th? That's sounding familiar, right?
Why isn't it the exponent?
Because it's a bigger number.
Because these are all numbers that are big numbers bigger than 10.
Oh, okay.
And if you think moving left or right, you have to think, which way do you have to think? Moving from new decimal to old decimal, I think. I always struggle with that one. Okay, how can I do this without just throwing it straight into the calculator?
3.7 times 4.5 and add the 5 and the 9.
Okay, so if we clean up that numerator, number piece times number piece. Now, I agree, throw this into the calculator if you want. What is 3.7 times 4.5?
16.65.
This is 16.65 times 10 to the,
14.
since we're multiplying and the bases are the same, you add the exponents, yes? Denominator is still 1.8 times 10 to the 4th. Now, I'm going to point it out, that numerator, technically, that's not technical scientific notation, is it? Because 16.65 is bigger than 10. But here's the deal. Am I done yet?
No.
I'll worry about it at the end if it's not scientific notation. Now what do I do?
Divide 16.65 by 1.8 and then subtract the 14 by 4.
Okay, so now we're dividing. Divide your whole numbers. What is 16.65 divided by 1.8?
9.25.
And that would just be according to the calculator. I'm fine with that. 9.25 times 10. Bases are the same and we're dividing, so we subtract the exponents. Now am I in scientific notation?
Yeah.
Yeah, so we didn't have to do anything fancy along the way. It all worked out in the end. Okay. Took a little longer than I thought, but I want us, if nothing else, you have a few minutes you can get started on homework. Nothing else, though. I need us to pull out the book, the iPad, something, and look at the homework. Make sure you understand what it is, where it is. Does that make sense? Okay, and maybe you've already started looking at it, but make sure we understand where to find it in the book, because I know it's been a few years since you've had to grab a page and do problems on the page, probably.